What's up, YouTube? So today I'm going to make a lecture video about Lewis structure. So kung mapapansin niyo, I haven't posted the lecture video for the last 2 years kasi medyo naging busy lang sa pag-pursue ng aking degree sa University of Santo Tomas. And today I'm going to make sa mga succeeding weeks natin ay gagawa ng mga lecture videos about a chemistry, basics chemistry topics. Okay? So without further ado, let's jump into the topic on the how to write a Lewis structure. If you notice that I will be basing on the PowerPoint. So if you want to skip the principles involving here, you can jump to part 2 of the lecture video and skip this and jump to the next video. So today, it is an excerpt from the chapter 8 and chapter 9 of Brown Chemistry, the Central Science, 12 edition, published by the Pearson Prentice Hall. So it is an excerpts na inapipaste ko lang dun sa may mismong book. But I will try to teach you on how to simplify it. Okay? So the Lewis symbols in the rule, which is a chapter on 8.1. The electrons involved in chemical bonding, yun ay yung mga valence electron or the outermost shell electrons that involves in the chemical bonding, such as in the case of sulfur, there are 6 valence electrons in its outer shell na yan ang involved sa ating covalent bonding. So, but that is not the topic today. But since you are going to draw a Lewis structure, ang Lewis symbol ng ating sulfur ay meron tayong S and 6 Lewis dots on it. But paano ba natin malalaman ang Lewis dot is titignan natin yung electron configuration niya dun sa may outermost electron. For example, lithium has a group ito ay 1 kasi nga ang valence electron niya ay 1. So for beryllium is 2 Lewis dot and so forth. Pero para mas mapadali, ang malalaman ninyo kung how many number of dots na Lewis symbol in a particular element is you need to take a look only at the periodic table. Let's say, for example, okay, lithium is group 1, therefore it has a 1 Lewis dot. Beryllium is group 2, therefore it has a 2 Lewis dot. Boron is in group 3, therefore it has 3 Lewis dots. And then for carbon is in group 4, so it has a 4 Lewis dots. So i-skip ninyo itong muna nating transition elements na to because they have d orbitals and they are responsible for a expanded octet. Nangyayari sa anion, but that is not the scope of our topic for today. Our topic for today is just draw a simple Lewis structure. So forth. Yes, you need a periodic table to determine what is the number of Lewis dot in a particular element. So we can see here, okay, does the Lewis symbol for the chlorine is correct? Yes, it's correct. Since ang chlorine natin is in group 7. Therefore, it is expected that it has 7 Lewis dots. So, 7 ba? Yes. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. And the third one, the Lewis dot symbols, is incorrect. Bakit? Kasi it has only a 5 Lewis dot, which is violet na. Hindi naman siya chlorine 2 positive, di ba? It is a neutral atom, so therefore it is expected to have a 7 Lewis dot. Okay? So the octet rules, the rule here is that para mas maging stable kasi yung atoms natin in a chemical bonding, it must follows in octet rule. Bakit? Kasi nga, if you notice that the noble gases has 8 electron configuration at wala tayong makikitang compound such as helium, neon, and argon because they are stable enough to stand by itself. Pero yung other elements natin ay kailangan nilang makipag-bond sa ibang elements to form a stable octet bonds in their valence electron. So, the vast majority of chemical substances na ikuan natin, dito itatakal natin, is more on covalent bonding on the Lewis structure. So, we are not going to talk about the metallic bonds, the ionic, but rather we are gonna focus on the covalent chemicals. So, since those are the covalent bonding substance that we often encounter in our daily life, such as yung tubig, acetic acid, suka, gasolina, na yon ay nag-involve ng covalent bonding. Yan. So, for example, this is the typical symbol of a Lewis structure. Such as, for example, two hydrogens will form a bond. So, magsasama sila. And then, chlorine, we can see here that nagkaroon din sila ng bonding between each other. And as we notice, ganito. But if we represent this into a line, ganito magiging itsura niya. Since line represents a two electrons ang nire-represent niya. So if we notice that the two Lewis dot here are coinciding and the bonding is occurred, and we can see that it obeys octet rule. Of course, with the exception of group 1 to 3, because hindi sila mag-obey ng octet rule due since they are only a containing 1, 2, 3 Lewis dot. For the other elements such as ammonia, yan, these are the representative Lewis structure of certain elements such as the hydrofluoric acid, the water or dihydrogen oxide, and the most simplest organic compound, which is the methane. And then, syempre, that what we saw in this previous slide, they are single bond. Of course, we are often encounter a double bond in a Lewis structure. In the case of this example, the carbon dioxide, that the carbon here and the oxygen contains a double bond. Why? Because kailangan nilang mag-obey sa octet rule natin. Kasi kung magiging single bond lang yan, the oxygen will contain a 7 bonds only, and for carbon, only 6. Right? So they have to obey octet rule to form a stable compound. So does it obey octet rule? Yes, because a bond line represents 2 electrons and 1 Lewis dot represent 1 electrons. And if we do the counting, they are all obeying octet rule. But syempre, hindi lang naman triple bond ang natin, double bond. We also have triple bonding that's sharing a 3 pairs of electrons, such as in the case of a nitrogen molecule. So the gist of this idea is that we have a single bond, double bond, and triple bond in order to obey the octet rule of the bonding in the atoms. So these are the rules drawing a Lewis structure. I'm gonna skim all of this kasi meron naman tayong example in the succeeding slides. Okay? First and foremost, sum the valence electrons from all atoms. Second is write the symbols of the atoms such as the Lewis dot. And then third is the complete the octets. And then draw the number of electrons. 5, if there are not enough electrons to give the central atom of an octet, try multiple bonds. Okay? In the case of example of this exercise, draw the Lewis structure of phosphorus trichloride. Okay? I'm just gonna dive into the whiteboard. And we can see here that so let's try to, this is an example, try to draw the Lewis structure of the phosphorus trichloride. Okay. First and foremost, sum the valence from all atoms. Okay, ano ba yung mga atoms sa present natin? Phosphorus and the chlorine. We have 1 phosphorus and 3 chlorine. So phosphorus is in group 5 elements. Take a look at the periodic table. Therefore, it has 5 Lewis dot. And in the case of chlorine, it is a group 7. You take a look at the periodic table, it has 7 Lewis dot. And nakita natin yan previously. 7 Lewis dot each. Ayan. And then, we can see here, the idea of this is that what if the cation is present and the anion is present? Let's say, for example, if phosphorus has a positive charge, remember this is just a hypothetical, therefore, ang number ng Lewis dot niya is just a 4 only. Why? Because Lewis dot represents an what? Electron. So, positive minus negative, of course, we will yield this. So, paano pagka naging positive to siya? Okay, of course, magle-less tayo ng 2 electrons. So, from 5, siya ay magiging 3 Lewis dot. Okay, do you get the idea? Okay, what about 3 positive? Okay, syempre, siya ay only 2 Lewis dot only, and so forth. Also with the case of protein. But sir, what if the phosphorus has a negative charge? Therefore, you add electrons. From 5, siya ay magiging 6 Lewis dots. So, yun lang naman ang point ng magiging ko natin. But however, this is rarely encountered kasi what we are focusing is to draw the simplest Lewis structure. In-state ko lang yung rule nung number 1 natin. Okay? So, to draw Lewis structure, first and foremost, ayan, natulad na natin number 2, the symbols of the atoms. And then, complete octets, so drawing na natin. So, first and foremost, meron kasi tayong tinatawag na 3 components of a Lewis structure. Meron tayong central atoms, and then we have a terminal atoms. Terminal atoms. Yan. Siyempre, intuition natin, ang central atom natin is yung nag-iisang element in this case. So, therefore, our central atom is the what? Phosphorus. Correct? Phosphorus is our central atom. And may makikipag-bond siya into chlorine atoms. Okay, chlorine atoms. So, 3 chlorines. The 3 chlorine atoms are bonded to phosphorus. So, pa-bond siya dito. Kung kuha siya ng tatlong bond, so, there are 3 bonds. Ang matitirang Lewis dot natin sa phosphorus ay only 2 electrons. Ayan. And then, the chlorine is bonded. The chlorine is bonded here. And the chlorine is bonded. So, the phosphorus is our central atom. And the chlorine are our terminal atoms. So, if you want to learn more on the Lewis structure, mag-search kayo sa internet natin para ma-drawing nyo siya in your intuition to do the Lewis structure. So first, pero hindi pa dito nagtatapos yung ating Lewis structure. Because we have a remained atoms in this case. Diba? Okay, let's just erase that. Okay, there are yung isang electrons dito ay naipag-bond, isang electrons dito ay naipag-bond, at yung isang electrons din dito ay naipag-bond. So, ilan yung natira for each of them? There are 6 Lewis dots. 6 Lewis dots for each chlorine atom. Yan, 6 Lewis dots. Okay. Does it all obey octet rule? Yes, because bond represents 2 electrons, right? So, in the case of phosphorus, there are 2, 4, 6, and then a Lewis dot represents 1 electron. So, in the case of this phosphorus, it has 8 electrons. Therefore, it obeys octet rule na. In the case of chlorine, so count tayo, 2, 3, 4, 5, 6, 7, 8. Also a octet rule. Yan. Since yan, octet rule silang lahat, they are all obeying octet rule. Ayan. So, in the case of this, so wala namang, lahat sila ay octet rule na. Therefore, multiple bonds does not occur here. Yan. This is the case, example of phosphorus trichloride. So, take a screenshot and para malaman ninyo for your future references. Now, let's go back at the topic. So, of course, in chemistry, there are always exceptions to the rule, di ba? So, there are molecules or polyatomic ions containing number of odd electrons. Meron din tayong fewer or less octet valence electrons. And meron din tayong more than octet rule. So, in the case of odd numbers, we have this example of nitrogen monoxide and nitrogen dioxide. In the case of this, if you notice that it only contains 2, 4, 5, 6, 7 electrons. Yan. And then, meron din tayong less than octet valence electrons because if you could recall the previous slides, that the boron is in group 3 and it is not in group 4. So, group 1, 2, and 3 often contains less than octet of valence electrons. And meron din tayong more than octets such as the phosphorus. It is capable of bonding a 4 to 5 bonds. Why? Because it has large atomic radius and it contains d orbitals. Of course, it is often encountered. And in this practice exercise, okay, draw the Lewis structure of the following molecules. So this one will be tackled in part 2 of the lecture video. So as I said earlier, if you want to go immediately at the practice exercise, skip this video. Okay? That's it. Thank you for listening. Let's dive in to part 2 of this lecture video. Thank you so much.